This part is about global navigation satellite systems, which is a superset of GPS, for instance. So the outline is the following one. So first we'll see global navigation satellite systems global properties. Then we'll study the global positioning system. First its basic operations, then how we use GPS augmentation systems and how they work. And finally, we'll see quickly other global navigation satellite systems such as GLONASS and Galileo. Let's start with the global introduction and properties. So the global navigation satellite system, as their name implies it, they are global, so they cover all of the Earth. They are navigation systems, so they provide navigation capabilities, so mainly they are used to locate devices. And satellite systems because they rely on satellites to provide the positioning feature. These systems can be defined by their accuracy, their precision. They provide the position of the device as longitude and latitude. They are defined by a constellation of satellites, and some of their properties and technical choices are bound to their history. So let's start by defining and distinguishing between accuracy and precision. Precision is the quality of the points that the positioning system will determine between all of them. So if you do not move, a precise system will compute points which are very close between themselves. So this is the real location, and this is the system estimate. So it's precise because the points are grouped together. Then the accuracy is the quality of the location estimate compared to the true location. So here we have the true location and we have some estimates. So this one is accurate, these ones are not that much accurate. They are far from the real location. And what we aim to achieve with a positioning system is to have both accuracy and precision, so the points are grouped near the real location. So that's a good positioning system. Then we'll define latitude and longitude because it's the type of coordinates that GNSS return as a location. So the latitude is in degree from 0 to 90, oriented north or south from the equator. So here you go to the negative latitude and here the positive. So it's also possible to tell, that's what systems do, some systems do, from minus 90 degree to 90 degree. The longitude, it starts at 0 from the Greenwich meridian here and go from minus 180 degree to 180 degree or 180 degree west to 180 degree east. So it's the WGS 84 coordinate system that we talked about during the GIS part. The constellation of a global navigation satellite system is the set of satellites which are orbiting Earth and providing this navigation satellite system service. So usually, always, these satellites are scattered over several orbits so that they will cover all of the Earth at any time. So here we see the 6 orbital planes of the GPS and the how the satellites are scattered on these orbits. So it's not regular, so that everywhere on Earth you always have at least 4 satellites in line of sight. So the GNSS history is strongly bound to spatial exploration, because putting satellites in space requires to know how to go to space. So 1957, Sputnik, the first satellite, it was a USSR satellite. From in the 60s and 90s and 70s, sorry, there was the transit system with an accuracy close to 1 kilometer, so it's not very good if you want to have accurate applications. In 1978, the first GPS satellite, followed 4 years later by the first GLONASS satellite, and 20 years later, or maybe 25 years later, the first Galileo satellite. In the origin, the GPS was only it was planned that it was only for the USA Armed Forces. As any biggest invention, it was to make war, of course. But in 1983, the Korean airline Flight 7 was shut down by Soviet army because it strayed from its path, since it had no precise positioning system inside. As a consequence, and to avoid any further type of such accident, the USA President Ronald Reagan announced that the GPS would be available to civilian applications. So it was a big decision that shaped a lot of things today. So in 1994, the GPS constellation was complete. 1 year later, the GLONASS constellation was complete. In 2000, the selective availability was discontinued. We'll talk about that a bit later because it's strongly linked with the military history of the GPS. And in 2004, the first Galileo satellite was launched, and in 2020 we still do not have the full Galileo constellation.